Okay, folks, we are approaching a level up point in our understanding of trig ratios here, which is exciting. That also means that this lesson is going to be a little bit tougher than the last couple. So make sure you really dig in on this video and watch and listen closely and take good notes as a reference. Okay, so you can see from our example here that we're looking at the value of a trig function of an angle bigger than 90 degrees. And this is what's new, right? Because before we've been stuck inside of a triangle, and a right triangle cannot have a 150 degree angle in it. Okay, so that is the change, and this is useful to us too, because remember what we are looking at, right, is we're building towards this understanding of these things as functions. So this is me saying I'm taking this function, I'm letting x be 150, right? So this allows us to plug numbers into this function that are bigger than just 90 degrees, meaning it allows us to apply the function in more real life situations. Okay, that's what we're building towards anyway. Okay, so the way we're going to tackle this is we're going to draw an XY plane like we did on a previous lesson. Okay, you will find it helpful too to label. You don't need to draw the circle necessarily, but label 0 degrees, 90 degrees is a quarter turn, right? 180 degrees is a half turn. 270 is 3/4 of a turn. And then 360 is a full turn. Okay, if you're into skateboarding or anything like that, you probably know those already. Okay, so we're going to draw the XY plane, and we're going to draw the angle. So 150 degrees is going to be past 90, but not past 180, but it's going to be a little closer to 180 than 90, right? So it doesn't have to be exact, but it should be roughly in the right spot. Okay? So notice, if I drop a line down to the x-axis, I have a triangle. Okay, so this angle is 150 degrees out here. This angle inside the triangle, well, these make a straight line, so 30 plus 150 is 180, right? So this is a 30, 60, 90 triangle. Okay, so because of the angles we've picked for these problems, you will always get something that shows up in the table. So I'm going to give you the steps. Okay, so here are the steps. We've already done the first two. So draw an angle on the XY plane. That was this, right? Step one is we just figured out how far we're rotating. Step two, create that reference triangle. That was this, right? So we dropped that line down to make a triangle. Now we're going to label our sides with the correct signs and solve. So that's when we're going to use the table. Or if you have these memorized, you don't need the table, but the signs is what's important. Okay, so the signs depend on what quadrant we're in. Okay, so I'm going to find tangent of 30 degrees now in the table, because that's my angle here. And we have opposite over adjacent would be root 3, would be my opposite side, over 3 on the bottom, but that 3 is going to be negative. Okay? So tangent of 150 degrees is going to be root 3 over negative 3. And the reason that it's negative, right, is because I'm to the left of my y-axis. Okay, so all the properties of the coordinate planes apply, right? And usually we don't write the negative in the bottom, so we'll just write it as negative root 3 over 3 like that. Okay, that's it. That's tangent of 150 degrees. We're going to do a couple more examples. Make sure you have good notes for all of them. You're drawing this XY plane for all of them, because drawing this picture is what's going to allow you to solve these. Okay, if you're not drawing the picture you're just kind of picking something off the table, you're going to get them wrong. Drawing the picture with a little bit of practice will get them right for you every time. Okay, so here we want sine of 210 degrees. So again, I'm going to draw my angle. So 90, 180, I'm going to go around. And 210 is going to be past 180. So there is my reference triangle. Now, Notice 210 is 30 degrees bigger than 180, so it makes sense that this angle here would be 30 degrees. So sine of 210 is going to correspond with sine of 30 degrees. I'm going to go back up to my table here. And notice sine of 30 degrees is 1 over 2. 1 over 2. Well, that's opposite is going to be a negative 1 over hypotenuse 2. Okay, so opposite being negative because it's below the x-axis, right? 2, the hypotenuse is always positive. You don't have to worry about that because the hypotenuse is not a coordinate, it's just a length. So we can't get positive or negative here. So we say sine of 210 degrees is opposite over hypotenuse, negative 1 over 2. And we don't need to simplify that at all. That's nice and convenient. So really this is just the negative version of sine of 30 degrees. Hopefully you're starting to recognize the pattern here. We're going to do one more. Okay, tangent of 315 degrees. So for this one, we're going to go all the way around. So 90, 180, 270, and then 315 degrees is going to be somewhere in here, right? So I'm going to draw my angle. And notice now, 315 is just 45 degrees shy of 360, right? So as I drop this line down, we're going to get a 45 degree angle there. Okay, so this is really a 45 degree angle problem. And remember, 45 degree angles, I could look at my table, but they're 1, 1, square root 2. So if I'm looking at tangent, I'm looking at opposite. This is going to be a negative over adjacent. This is going to be positive because I'm to the right of my x-axis. Okay. So tangent of 315 degrees is going to be equal to opposite, negative 1, over 1, which is just negative 1. Oops. That's it. So again, the steps here, draw the angle, figure out this reference angle here between the angle you drew and the x-axis, and then figure out the signs based on which quadrant you're in, right? And then your answer should match one of the values in the table we've been using, except for maybe the signs. Okay. The last thing you need to know about something like this, right? So find the tangent of 270 degrees. These are easy, you'll just memorize these. But you notice why this one is weird is because it's on one of the axes, okay? So Delta Math gives you this table if you hit C example or get one of these wrong. I want you to just have this table in your notes for these. So here are your boundary angles. So here we would say, well, what's tangent of 270 degrees? We'd say that's undefined. But you should have this table in your notes as a reference.